school that was paying free. You know, cheap, but that was never free. I think they take stuff as free.
It's kind of like a sourdough or like
All the nations.
All right, everyone. If I could grab your attention. Okay, so the last presentation for this evening. So I'm going to talk about a Linux Foundation project called ONAP, how it enables 5G and edge computing, and then talk about how CDAP is used in it and what purpose CDAP serves. So in this sense, it's a very different presentation than the previous two. I don't have a demo, and instead I'm going to talk about the use case, the ONAP use case. My name is Amar Kapadia. I work for Aarna Networks. We are an open source company around the ONAP project. I'd also like to point out Srini, he is here. He is part of the technical steering committee for the ONAP project. So at the end of this presentation, I hope that some of you will have the curiosity to learn more about ONAP, maybe explore it, maybe even contribute. All right. So if anybody here isn't aware of that, let me know. I'm assuming everybody's heard about this many, many times. 5G and edge computing, also called multi-access edge computing, is going to be a massive opportunity. It's going to be as disruptive as when cell phones first came out. So it's 2G, 3G, 4G. This is going to be much more disruptive than any of those generations, simply because of the much higher bandwidth, much lower latency, and something called network slicing, where operators will be able to create virtual networks with different SLAs for different entities and operations. So if you are autonomous cars, you will get, maybe you want low latency. If you are video streaming app, maybe you want high bandwidth, but you don't care so much about latency. So because of this, 5G and edge computing are going to unleash augmented reality, virtual reality, tactile internet, 4K video, and I think we don't even know what applications will show up in 5 to 10 years. It's going to be a very interesting future. And just to sort of shock and awe, it's a $10 trillion 5G economic output according to one market research company by 2035. So it's not a small opportunity. You can see governments jockeying for it, squeezing out vendors from each other countries. So this is a big deal. Networks so far have been built using physical boxes. Buy a bunch of physical boxes, you change them up, you manually go configure them, and you have your network. That's going to completely change. So next generation networks will be software defined, no surprise to this audience. They'll use technologies such as NFV, which is Network Functions Virtualization, where you take a physical box and you replace it with a VM or a container, as the case may be. SDN, software defined network, so your switches and other network elements are only data plane. They have no control path, and the control path is centralized and managing your entire network, which gives a lot of efficiencies. And the cloud technologies goes without saying. Also, open source is going to play a big role. Open source plays a big role in enterprise already. We all know that in this room. But in the communications sector, open source is relatively new. But for the same reasons it's done so well in enterprise, it's going to play a significant role. And I'm going to go a little bit fast. I know we are maybe running a little late, so I'm going to speed up a bit. So what is the software architecture going to look like for NFV in general and 5G, which can also be applied to 5G? So I'm not going to go through this in excruciating detail. On the left, you have the data path. On the right, you have the control and management plane. So you have NFVI hardware, which is commodity servers, standard switches, maybe even white box switches. And storage is essentially servers as well, just generic x86 or ARM servers. So you have generic hardware, you have hypervisors or containers running on it, orchestrated by OpenStack or Kubernetes, as the case may be. VMs orchestrated by OpenStack, containers orchestrated by Kubernetes. That's the control plane for NFV infrastructure, network functions, virtualizing infrastructure. Then you have VNFs. VNFs are, just to make the terminology and jargon really confusing, you have NFV and then you have VNF. So VNFs are virtual network functions, which are physical boxes available as VMs or containers that run on hypervisors or containers. And then you have management systems on top. Right-hand side, I'm not going to go through a lot of detail, but you have management, orchestration as the primary functions on the right-hand side. And then you have service assurance, which is simply another way of saying automation. So automation without human intervention. So that's what you have on the right-hand side. And this becomes very important. Why is it important? I'll tell you the next one. So this shows sort of a progression of how sophisticated telecommunications networks get over time. So initially, people said, you know what? These physical boxes are a pain. We have thousands of them. Let's consolidate to 10 types of commodity servers, virtualize our functions, and life is good. We get operational savings. We can share our hardware across different services. We get some capital expenditure savings. So that was the beginning. But then people said, you know what? We want multi-tenancy. We want dynamic. We want to be able to rip out certain services dynamically and push new services. We want a cloud stack. So that's OpenStack or Kubernetes, essentially. But that's not enough. Now, next thing is you say, yeah, I have a virtual infrastructure. I can create VMs or containers or pods automatically. But my network services still have to be deployed manually, configured manually. And that's okay if you're doing it once in 3 months. But with 5G, if you're doing it once in 5 seconds, there's just no manual doesn't make sense. So it has to be automated. So that's where you have automated orchestration and lifecycle management of network services. So let's say we talked about this network slice, right? I'm Tesla, and I say, hey, I need a network slice that's this bandwidth, extremely low latency, high availability. I don't want my cars to start running into each other. Please give me a slice like that. So that slice has to be created dynamically, and then maybe half an hour later I don't need the slice, so I give it up. So that has to be automated. And then finally, you get to a point where you say, please don't open tickets. If there's fault management, performance management, any issues, the system should be able to sort of take care of itself. So that's automation. And again, you can imagine if your system is so dynamic, every few seconds something is changing, you want full automation. So this is where you need, this is what 5G and edge computing needs, and that's where a sophisticated automation tool is required, and that's where ONAP comes in. So now that introduces ONAP. ONAP is a Linux Foundation project. It stands for Open Network Automation Platform. And in their language, it's a comprehensive platform for real-time, policy-driven orchestration and automation of physical and virtual network functions. So I talked about virtual network functions, VNFs, but in 5G, you also need to support physical network functions, because some things like your radio, with heavy DSP, it doesn't make sense to virtualize it. It requires hardware acceleration, DSP, whatever. So leave it as a physical network function. It's 100% open source, part of the installation. So it's a relatively new project in terms of, it was born in March of 2017. The first release actually came out at end of 17. So it's year and a half, 2 years, depending on how you count. is a well-supported project.
Okay.
It actually came out of two projects. AT&T open sourced a bunch of their ecom code. They had some code to use that they used internally called ecom. And there was a Linux Foundation project called OpenO. And so when this project was born, there was actually a merger. These two projects merged. What I find unique about this project is a lot of projects are heavily vendor-driven. This project is extremely heavy in terms of operator participation. So you see how many operators are behind this. I didn't even sort of have space to list the vendors. So this is only a list of operators. And these guys are very active in this project. So, time check. So I'm going to very quickly tell you what ONAP is, and then jump over to why do you need big data or CDAP in it. So ONAP, 3 components: design framework. So there's a clean delineation between design and runtime. We are not trying to create silos, but we want people to be independent and do their jobs without having to depend on each other. So designers can do their job without depending on ops. Ops can do their job without depending on design. So clean delineation. Runtime, you have 2 pieces. You have orchestration and lifecycle management, and monitoring, service assurance, aka automation. So as you can imagine, this is where CDAP comes in, and we'll talk about it more. So I'm going to skip this. This shows how ONAP fits into other software systems within telecommunications operator. ONAP is actually a very well thought out system. And if you look at it, it sort of has, I find, it has some of the original thinking of Unix style where, deep thought has gone in the architecture. So this lists only 3 of the principles. They have many more. But the 3 principles are model driven. The whole point is we want people to be able to change the behavior of the platform without coding. Because there's only so many software engineers in the world, and if 5G and ONAP, if everybody has to be an engineer, it's not going to work. So that's the point of model driven. There are Tosca models, heat models, YAML, etc. There's lots of models to change the behavior of the platform. It's cloud native. ONAP is containerized and is deployed using Kubernetes and Helm. So it's already there. And the goal of ONAP is to deploy containerized network functions. So that we're not quite there yet, but in a couple of years, I think it'll be. Right now, it's heavily virtual machine based. So although virtual machines and cloud native are not contradictory, you can have cloud native virtual machine. So that's another one. And then the third one is DevOps. What we are experiencing on the enterprise side is starting to happen in telco. You have different VNFs. You have Kubernetes. You have OpenStack. They're not all coordinated and showing up every 18 months, right? You're getting one VNF in March. You're getting next version of Kubernetes in April. So you need a CI pipeline, and you need to be able to cut over these changes into a production network continuously. You can't wait 18 months and do a forklift of upgrading. So ONAP is built using CI/CD, and it deploys network services using a CI/CD philosophy. Right now, I would say it's more CI. It's not CD. That's the goal. So I'm not going to go through. So don't worry. I'm not going to go through this. Just to make some points, there is a block called ONAP Operations Manager that's based on Kubernetes and Helm. So ONAP itself is a containerized cloud-native application.
Okay.
It's not going to deploy and manage its own lifecycle. So you have that, which is Kubernetes Helm-based.
Okay.
Then you have design time, lots of tools to do your design thing. And the whole philosophy of ONAP is we want to enable non-engineers, people who are not as sophisticated at coding. So a lot of those tools are very simple to use with that mindset. On this side, you have service orchestrator and controllers, which first they deploy the network service. So you want a 5G network. The orchestrator will deploy the whole thing, every function, then it'll configure the whole thing, get the whole thing running. And then it'll manage its life cycle. You want to scale up, scale down, wrong words. Scale out, scale in. You want to self-heal, you want to terminate, you want to upgrade, that's all going to be done by this left-hand side.
Okay.
And on the right-hand side, there is something called Data Collection, Analytics, and Events / CDAP. And what happens here is everything you want to monitor goes in there. And the CDAP framework gives you collectors and it gives you a programming abstraction layer. So it's convenient from multiple aspects. So the idea is events, alarms, metrics, logs, files, SNMP, whatever you want to monitor, everything goes in here. You have a big data framework, and you can create a data pipeline like you saw in the last talk, and through that data pipeline you can run sophisticated analytics, and that generates an event which goes to something called a policy engine. So the policy engine then says, do I need to do anything about this or ignore it? And if I need to do something, what do I need to do? And those actions typically drive the orchestrator or one of the controllers into doing something. So that's really the idea. On top you have APIs and GUI, and below this you have a cloud. So all of these services, DNFs are getting deployed onto a cloud. So the cloud today is OpenStack, but soon it will be Kubernetes as well. So again, I'm probably not going to spend much time. Third release, Casablanca, came out in November. What I like from this pie chart is the distribution of contributors is uniform-ish. Right? You don't see like 90% of the code is contributed by one company, which tells me that the project is healthy and well represented. This is DCAE. Does this look familiar to anybody? This is basically the CDAP, one of the CDAP pictures. So this is CDAP. So DCAE is CDAP. You have collectors at the bottom. You have all kinds of data collection, and then analytics microservices, which can form data pipelines. And then there's a whole infrastructure to manage the life cycle of DCAE. So you can start, stop DCAE, you can deploy DCAE elements, you want a controller somewhere, you want a data store somewhere. All of this distribution of components, lifecycle management of DCAE is also part of ONAP. That's all taken care of. And this is going to get really exciting when we go to Edge, because in the core, we will have the full-blown DCAE, and in Edge, we will have subsets, because Edge is a very constrained environment. But you need to run there's some level of analytics you need to run locally. So you're not going to send everything to the core. So why CDAP? So why did the ONAP community pick? This choice was made way before I got involved. But the reason is it fits with the core ONAP philosophy of allowing non-programmers to use the platform. So big data, as you all know, is not easy to use, right? It's not for the faint of heart. And telco is highly unfamiliar with big data. I mean, you say Spark, they'll be like, what is Spark? Hadoop. Oh my God, what are you talking about? So the whole, in fact, if you look at ONAP documentation, it sort of doesn't even talk about big data frameworks. It just talks about things in terminology that these telco operators are accustomed to. So that's the main reason. And then you create DCAE templates, aka CDAP pipelines, by chaining microservices, and these microservices can be collectors, analytics applications, etc. And you have closed loop automation. So it's pretty powerful. ONAP is heavily focused on 5G and edge. Again, there's a lot of jargon. I'm not going to go through this for this audience, but ONAP is looking at every aspect of 5G and how to enable it. There's a similar effort for edge. I don't have a slide on that. There's edge work going on as well. Now, I think I'm on to my last slide. So ONAP is too big to try out on a laptop. So what do you do now if you want to try it out? So my company, Aarna Networks, we have created a distribution, ONAP distribution. It's easy to install. So a lot of the manual steps in deploying these hub charts using Kubernetes, that's all it's scripted, made easy. Configuration is made cleaner. It's made compact. So we've used CDAP all-in-one. Even so, it doesn't fit on a laptop. But by doing so now, at least we can go to Google Cloud. So it's available on GCP for a free trial. And of course, it's available on Terminal. So if anybody wants to give it a shot, please try it out. And like I said, if anybody wants to get involved, come talk to me or talk to Srini.
All right.
With that, any question?
Who's got a question?
So, you have this bit about all the telecom operators using that the ONAP system, right? And so your company has actually created a cleaner, like easy to set up distribution of it. And what part of it includes the CDAP pipelines? Like how do you help customers configure that and help them choose what parts of the ONAP lifecycle they want to track and create those pipelines?
So you sort of have to use the whole thing. There are some projects that are discretionary, you may or may not use, but you have to use the orchestration side and the whole DCA side, DCA policy side. Because if you have CDAP/DCAE, it has to be able to provide an action to the orchestration and lifecycle management side. So you need the whole thing. Now, how do we help people define those pipelines? There's 5 blueprints that the ONAP community has created, and each of those blueprints have a closed loop automation pipeline that shows you how to connect events, monitoring data to DCA, and then how to configure DCA to trigger actions. So we typically start with those and then build on those.
What do you think? Who is the current world leader in 5G? Is Huawei, Ericsson, or what company leader? Top 3. Name top 3.
So that I don't know. So that's kind of beyond. I can tell you the top 3 people who are contributing to ONAP, but I don't know that.
Okay, that's it.
So will this be, will ONAP be the common stack of the operators you mentioned? If so, how do they plan to differentiate themselves towards customers that effectively use this extension?
So I believe so. I believe this will be the de facto management and orchestration platform. There is one other major open source competitor, and of course there are proprietary competitors as well. But how will they differentiate? I think their whole value is in network services, workloads, applications. So it's the same question as how do two companies, both using Google Cloud or Amazon, how do they compete, right? So the differentiator is not in the cloud. The differentiator is their workloads and their business models. Same thing here. So ONAP itself is not going to differentiate the 5G software.
Another question. What do you think about the AI play in this 5G?
So that's actually a really good question. So AI ML will be microservice that will be used in a DCA template / CDAP pipeline. So there are many companies who are already working on using telecom network data and training the AI engines, and then providing an inference engine that will be used as part of this pipeline. So there are many efforts and many companies working on this. It's really a hot topic.
It's probably an edge story more than a cloud story.
Both. Because you have different types of AI ML analytics you want to do at the edge and etc. All right. Thank you very much.
Thank you to our speakers. If you guys haven't grabbed t-shirts on your way out, definitely do so. If you have other questions, speakers are around. A bunch of some folks are hanging out doing their blue tags.
And also, within 2 days, more or less, I'll upload all the videos and the presentations on the Meetup page, so you'll have access to all the information and all the links that were shared before as well. And a big thanks to Ascendo.io for hosting and sponsoring today's Meetup. So thank you.
Thank you.
Thank you all for coming.
See you all next time.
Is that your friend?
Huh?
Is that your friend?
Well, yeah, right. The open, the whole thing. I would ask him if he's going to be at scale.
Oh.
Have you heard of scale? Right here. It's one of the largest community-run conferences in the United States. It's open software and the open movement along with Linux, DevOps, like that. Microsoft was even there. Took 3 booths.
Oh, wow.
And it's a pretty fun-loving place. The people that attend there have to not tell their employer they're going. Because they might be, we call it headhunted.
Oh, I see. Okay.
You know what I mean? So they travel from all over the world on their own dime. And they have a game night going on 17 years in Burbank in March. It's really a very fun event. Lots of things, everything, Raspberry Pis, pretty much every geekish thing you find in the geek hangout. Really, literally. We used to have 16X or 17X, and it's relatively reasonable. For 4 days. Yeah, starts Thursday, Friday, Saturday, Sunday, and we have a lot of cool stuff. Lots of cool companies. It's very fun loving. It's one of the better trade shows. Huh?
How many people are there?
About 4,000. It's from all over the world. And you've got big data people, you've got Blender people, the software that makes animation.
Oh, okay.
So I'm actually, my second project is book. Go ahead. Yeah.
You want that? Okay.
Well, it was a pleasure.
Yeah, nice to meet you.
Check out my website. Yeah, I've got some work. I've got to work on my hiatus until I